Hello, and welcome to my presentation. This presentation, if you saw the title and read the abstract, is all about how Gerald Moni uses QGIS. Um, he learned this skill for the Tennessee Cave Survey to aid the organization in increasing its accuracy of cave entrance locations. He's greatly improved the data set as a whole by LiDAR correcting and updating entrance locations as well as field checking. So I'd like to thank him initially for that. So this presentation is going to walk through this document. For the most part, this was created by me and also edited heavily by Gerald so that it works for him. It's a little more user-friendly than what I initially sent. And it just walks through kind of what QGIS can do and then the step-by-step of how he uses it and what works best for him. If you're interested more about QGIS, the Survey and Cartography section of the NSS has created a video online that is extremely helpful, kind of going over the basics of QGIS and all that it can do. So I recommend reaching out to them and taking a look at that if you're interested. But let's go ahead and get going with this presentation. So data download was the first step. So if we look at our document, it talks about GIS basics, kind of goes over different data types, kind of jumps around a little bit, but we're going to start off by going to this website right here. It's the NRCS website. So I'm just going to search it in my preferred web browser, click on the first thing that comes up, and then it comes up with this page, and we're going to go down here to direct data download. So here you can browse different types of data depending on what you're looking for. But if you're unsure of what you're looking for exactly, go back to that other page and then you can click on a place, order by a place. So where, it's the first step. So we're looking for a state, we're going to go with Tennessee. Then the type of place, so that can be this whole state, a congressional district, a county. We're going to go with the topo sheet for this because that's how Gerald works. And then we're going to enter Cookeville East. So where convention was held last year, hit Find Places, go click on Cookeville, brings it up. You can make sure, oh, hey, look, that's actually in Cookeville. And then we're going to click Select this place. Now this is the what data. If we're wanting to download multiple types of data, we can click multiple boxes. There is a file size limit, but we shouldn't be able to hit that on this tonight. There's lots of information listed here. You can download census data, climate data, and so on. What we're particularly interested in is this LiDAR elevation data set, the Bare Earth DEM, with a 1 meter resolution. So we're going to check that box. Then we're going to scroll down. They've also got some Bare Earth hillshades. We're going to end up creating our own using QGIS. We don't need to download that. Geology would be helpful. And then also some roads. Down here towards the bottom, we have transport lines, so primary roads. Then I'm going to continue here. So select the format. What format works best for us? I'm just going to choose Esri shape. It's a shape file. It's a fairly generic GIS data format that can be read by most software. The inclusion down here, I'm going to change this from standard to extract. This will give me just what's in the topo quad and nothing around it. So onto the delivery, I'm going to hit continue, and you can type in your email address and hit continue. And then once you do that, you'll be sent another screen, and then they'll send you an email once your data is downloading, or once your data download is ready to go. It'll be a zip file. So once you download that data, here's one that I've already downloaded. It's a zip file. We're just going to extract this here. I'm going to go back to our NSS logo. I'm supposed to be showing that throughout the presentation. So as you can tell, this is a fairly large file. It takes a little bit for it to extract here. So LiDAR data is very dense, but it is very high quality most times. Go ahead and get rid of that. And in this elevation folder, there's a couple different files. Those kind of all go together. This is a metadata file if we want to read about that data. Here's a TIFF image, and then some overview files to help it draw faster. So I have downloaded a fresh copy of QGIS 3.10, and that's what we'll be using tonight. So this is it as soon as you open it. So I'm gonna start us an empty project, and then we're gonna go up here to add data. So we're gonna add a layer, and we're gonna add a raster layer. So you can also add vector data here. Vector data is for those transport lines, but raster data is what we're interested in. And I've actually already bookmarked this folder over here. So I'm going to bring this in, look at what we're bringing over. I'm going to bring in the TIFF file, just drag it and drop it here. Should take it a minute. It'll say, hey, is this okay? We'll just go ahead and click yes. It'll bring it up here. So this is the Cookeville East quadrant as shown by elevation. The darker elevations, values from 275, are lower, and the white elevations are higher, up to 577. So I know from this area that those values are in meters. And so since Gerald works in feet, we need to figure out how to convert that. So we're going to go up here to Raster, and then Raster Calculator. And this, we can apply just about any type of math to this feature and the values that are within it. So I'm going to choose our TIFF there, and then times 3.28. We're going to use that as our conversion, change this from meters to feet. And then I'm going to select our output layer up here. And I'm going to say elevation feet. We can choose our format up here. I typically use an IMG file, but we can just keep rolling with it like this. All right. And it takes it a minute to run. This is quite a bit of data, so we'll just let that spin. All right, so that finished running. So over here in our table of contents, I'm going to drag in this IMG file. All right, and we can go ahead and turn off this layer. If you look, it's pretty much the exact same, but those values have changed from the meters to the feet. So I'm going to right click on this and remove this layer because we no longer need it. So if we zoom in on this area right here, I know from previous experience that this is a bunch of sinkholes and this is a quarry right here. But it's kind of hard to make out. So we're going to go here to these, double click on this. Then the symbology will come up. We're going to take a gander through this right here. So the render type is at single band gray. We choose this dropdown and change that to hillshade. We can set the azimuth of the sun, set a Z factor, set the altitude of the sun. But I'm going to keep those all the same. I'm going to resize this and then hit apply. If you look at, see what this has done, this has basically taken our surface and made it look like the sun is shining on it. So these darker areas and the lighter areas where the sun is hitting and not hitting. But that makes it a lot easier for us to see the data that's on this. So this is a large active quarry, as you can tell. And then up here on top of the hill, there's a bunch of sinkholes. Chances are at least one of these is a cave. In this area, there's caves that are everywhere. So this hillshade is one way to view the data, but not everybody likes doing that. Definitely not Gerald. So we're going to turn this back to single band gray. If we don't like that color, we can change it. Color gradients right here, white to black, black to white. We can also choose other ones, make our own, do whatever we want. But we're going to come up here to the raster drop down. And if we look under here, that's where Raster Calculator was, we've got all this analysis stuff, and then we've got a bunch of other projections, miscellaneous, extraction, and conversion options. We're going to choose contour. So our input layer will be elevation feet. The interval between contour lines, Gerald usually goes with 3. And then the attribute name is elevation, that's what it's displaying. Where do we want to save it to? Click these little 3 dots. Save it to a temporary file, but I'm going to save it to an actual file. Go back to our folder here. Call it contour 3 so I know which one, what the Z values of those are. And the save as type, I usually just go with a shape file. It's a very generic file as well, in case I'm using other software. And then you can go ahead and run it. And that'll take a little bit to run. All right, once that finishes, you get this nice, lovely screen here. These defaulted to the purple color, but we can update that if we want. Just double click on that menu, and you can come here. You can choose whatever color you want. You can punch in your values, spin the wheel, drag it around. We're going to make those this nice shade of yellow. All right. So this is easier for some people to read the map, harder for others. But we can start zooming in here on these sinkholes again. We can really see the bottoms of the sinkholes very well. So this is, if you've been reading contour lines your whole life, you can easily read it. If not, then you should probably learn how to read the maps. But this is a double crested sinkhole right here. And this is how Gerald does things. He navigates around, zooms in on the sinkhole, tries to figure out the elevations. To do that, we can use this little identifier tool up here, the one with a little eye. Then we can click on these features, and it should tell us the elevation values. So that one we got the elevation of 1,332. And that one's the same value. But we can just pan around, clicking different things, checking our coordinates on that, making sure we get the right elevations to update information with. All right, so if we're looking for the coordinates to update a cave entrance from the hillside over here to the bottom of this sinkhole, down here at the bottom, it's displaying the coordinates, but those are in state plane feet. So the TCS stores things in degrees, minutes, seconds using that WGS 84 and not state plane feet. So we need to update that. So in order to update that, we're going to come up here to Project, then come over to Properties. So bring up another menu with a bunch of different options. What we're interested here are the measurements. So our ellipsoid, we're going to go ahead and update that to WGS 84 down here at the bottom. And our distance for measurement, well, that's feet, of course. We're in Tennessee. The area unit, we can change that to square feet, but we won't be using that. Coordinate display, we're going to want degrees, minutes, seconds. If we hit OK, this will update down here. So if we're scrolling around, want to know the coordinates of this sinkhole, put our cursor there, and it tells us exactly what that coordinate is. So we can write that down, come down, copy and paste the value. I usually try to line things up about like this so we're real close. Come down, copy that, paste it into our spreadsheet, update that coordinate so it's most accurate as we can get. If we're wanting to measure the size of this sinkhole, I can come up here to this ruler thing. That brings up the measurement window. We can measure from one side of it over here to the hillside. It's about 380 feet for that first segment. We can click multiple segments. We can come down here and start a new one and do the same thing. But that's how we measure. All right, let's say we weren't sure where the cave entrance was and we were trying to generate a point file that we could load to our GPS. We can go out and field check some of these. The way we do that is we can come up here to this third button over. This is the new shapefile layer. So our file name, we can put it in the same folder I've been putting everything else. And we're going to call this points, or GPS points. The type is a shapefile. The geometry type will be point. We're going to use WGS84. And we're going to add a couple of fields to make this easier on ourselves later. So we're going to go ahead and add a longitude field. And the type will be text. The length, I'm going to shorten that down to 15. We don't need it to be 80. Then we're going to select this Add to Fields list. Do the same thing for longitude. Keep it at 15. Text type. Add the field, and then I'm going to put a name field in here so we can name some things. I'm going to bump that up to 20 feet. And then I'm also going to add a description field. We're going to make this, let's say 200 characters, just in case we want to add some more information in there. So now that we've got all those, everything's looking good. Go ahead and hit OK. And then down here, we've got this new layer that's been created. So I'm going to switch back to this DEM view. And I'm going to switch it also to the hillshade view again, just so things will run a little bit smoother. So I'm going to just change the render type down to hillshade. And then, all right, we've got a couple of points that we're going to mark here. So I'm going to select our GPS points. I'm going to come up here to the yellow pencil and toggle the editing. And 2 buttons over kind of appears, and it's add point features. So I'm going to drop a point right here. This nice new thing comes up. I'm going to call this point 1 for our name, description, large sinkhole. We're going to come back and add an ID will be 1. We're going to come back and attribute the lat and the long information later. Point number 2 will go here. We can put whatever notes that we want to in there, and then I'm just going to put a couple of other features here. Now that I've got those, I'm going to go ahead and save my edits by clicking the floppy disk and toggle editing once again. So if we right click on GPS points, we come up with a menu, and I'm going to open the attribute table. So this has all those attributes that we created. The fields are in here, and we can edit the data here. So what we're going to do is we're going to go up to our field calculator tool. So for this, we're going to come down, we're going to update the existing field, and I'm going to choose lawn, and just realized I did lawn and long, but we'll pretend that's long and lat. So I'm going to come down in this to geometry, expand that, and we're going to call this the X coordinate. So I'm going to choose this $X here and hit OK. And it populates that for me. We're going to do the same thing for this other one. Update an existing field. Choose the other one, and we're going to call this Y. Or this will be our Y field under geometry again. Scroll down, $Y, and OK. So now we have the X and the Y's right here. So we can copy and paste those values, convert them to degrees, minutes, seconds. But those are one way to store data. So I'm going to close this. I'm going to save my edits again. I'm going to toggle my editing so I don't create any more points on accident. Now this data is currently a shapefile, but if I wanted to create like a GPX or a CSV file, I can come down here, right click on it again, choose this export option, then I go to Save Features As. This window, up here at the format, you got lots of different options. So let's say I want to save this to a comma separated value table. Choose my file name. So I can call this points. File type's already filled out. Choose your CRS, which is irrelevant for the CSV. Go through all these different options, but we're just going to click OK. And once that runs, this one added to the map. And we can open this up as an attribute table, and it's the exact same. What we can also do is we can come into File Explorer, go to wherever we save that, and point CSV, and it's going to want to open that in Excel. So we can go ahead and open that up. And once that opens, we can see we've got those fields and the information is the same. So we can use this to do whatever we want to do, update values, put in more information, append the features maybe, but we got lots of options there. So that's the basics of how QGIS is run. When in doubt, right click it or double click it. There's usually lots of menu options that you can pull up and just click through those and you should be able to find it. If you want a copy of this document, I can remove the sensors for you and email it to you. Feel free to reach out to me for that. But that's all I have for us for now, and thank you for watching my presentation.